Hello! Today for our lesson we are talking again about area. Yesterday we learned that area is the measure of space inside of a shape. And we measured some shapes yesterday using triangles. Today we're going to measure shapes using triangles, rhombuses, and trapezoids. The first shape that we're going to measure the area of is this shape right here. It's a caterpillar. That's what we're going to call it today. I know it might look a little different than caterpillars that you've seen before, and that's okay. The first thing I'm going to do is measure my caterpillar using the green triangles, and then I'm going to measure my caterpillar using the blue rhombus. So I'm going to think about what I notice about this caterpillar. I notice right away that there are 3 large parts to this caterpillar. And I know that those large parts, those shapes, are called hexagons. So that's one thing I already notice. Another thing that I notice about this caterpillar is that there are lines inside of my caterpillar breaking up each of those larger shapes into different triangles. So that's another thing that I notice. Now that I've noticed a few things, I'm just going to count those triangles that I see, but instead of writing a number in every single triangle, I'm just going to write a couple numbers in different triangles as we go. And I'm going to change my color here to green because I'm using the triangles. So I'm going to start counting with 1, 2, 3, 4, 5, 6. There are 6 triangles so far. So now I have 7, 8, 9, 10, 11, 12 triangles. And now I'm counting 13, 14, 15, 16, 17, 18 triangles. So I have 18 triangles inside of my caterpillar. So a triangle equals 1 unit for my first little problem here. So if a triangle equals 1 unit of area, then the caterpillar is 18 units, the whole caterpillar. So now what I'm going to do is I'm just going to erase all my numbers here. And I'm going to think about how many rhombuses it would take me to fill in my caterpillar. Now I'm going to use my drawing tool again, and I'm going to change it to blue so we know now we're talking about rhombuses. And I can't see my rhombuses right away, so I know that I need to kind of draw them in. So here's one rhombus, right, 1 there. And if I look and I kind of look at a rhombus turned sideways, I can see 2 right there. And then I can see another one will fit right in there. I have 3 rhombuses. Now if I do the same thing I did on this next one, I see 4, draw another one, I see 5, draw another one, and now I see 6. Almost done. I'm going to draw another rhombus to see 7, and then I see 8, and then one more, I see 9 rhombuses. So now on this problem, if 1 rhombus equals 1 unit of area, what is the area of the caterpillar? Well, the area is 9 units, or 9 rhombuses. But what I'm really thinking about as a good mathematician is I'm thinking about how much space is inside of my caterpillar. Now, the amount of space has stayed the same. The only difference is what my tool is. So if my tool is a triangle, then I can fit 18 of these triangles inside of my caterpillar. But if my tool is a rhombus, I can only fit 9. So now I'm thinking, what is the relationship between 18 and 9? Well, if I draw a line right in the middle of my rhombus, just like yesterday, I now have 2 triangles. So I know that 1 rhombus equals 2 triangles. Or 1 triangle can be 1/2 of a rhombus. That's the relationship I'm thinking about today. Now we're going to look at a different shape. We are going to look now at this star shape that you see above our caterpillar. Now in our star shape, we're going to think, just like we did before, of how many triangles we can fit inside of our star shape. So I know that I can see the triangles already because the lines are there for me, just like this. All of the lines are there for me to see, to break up my star. So I know that if 1 triangle equals 1 unit of area, the area of the star is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that the star is 12 units when we're using triangles to measure. But if I'm using a rhombus to measure, the answer is going to be different. Now, instead of drawing all of my rhombuses into my star, I'm going to think about my caterpillar again. And I knew that if I had 18 stars down here, or 18 triangles to make my caterpillar, well, I know that you can fit 2 triangles inside of a rhombus. So then I would need half as many rhombuses for my caterpillar. Now, if I only need half as many rhombuses than triangles for my star, I'm thinking about what is half of 6? Or what is half of 12? Oh, well, if you're a thinker, Miss Tyne just gave you the answer, but I'm still going to show you. You can take that 12, and we know how to split it right in half. It's a double. So we'd have 6 and 6. If it takes half as many half as many rhombuses than triangles, we already know that it's going to be 6 rhombuses. If 1 rhombus equals 1 unit, the area of the star is 6. And I can check by putting in 1, 2, 3, 4, 5, 6 rhombuses. So we're thinking about today, what is the relationship between our different shapes? How many triangles can we fit into a rhombus? And what does that mean for our area? So when you have your work today in Seesaw, you're going to see a page that looks like this. It's called What It's Worth, or What's It Worth, excuse me. And you're going to see 4 different pages for this assignment. Now on the first 2 pages, you're going to have the same shape, this diamond. The difference is, on your second page, you don't have your triangles already drawn in to help you like you did before. We had all these triangles drawn in so we could see how many triangles we were going to have. Now, you're going to have to do a little extra work by moving around your triangles to see how many you can fit, or moving around your rhombuses to see how many you can fit, and then moving around your trapezoids to see how many you can fit, and in what way, without the lines to help you on page 2. So that'll make it a little more challenging. If you want to try it with a little more challenge, you can go to page 2 and try it on page 2. Now for our second shape, you're going to have this flower on page 3 with what it's worth. And just like on the diamond or on the rhombus, you're going to have to find out the area using triangles. How many triangles would you need? The area using rhombuses. How many rhombuses would you need? Just like we did in our example. But then something new is the trapezoid. So you're going to have to see how many trapezoids you would need. And then you're going to have to think about what you notice about your results. Like we noticed before in our example with the star and with the caterpillar, we noticed that we needed less rhombuses because a rhombus is 2 triangles. It's the same size as 2 triangles. So that's the relationship. You'll need less rhombuses because they're bigger. And that's what you need to explain at the bottom where it says, what did you notice about your results? And if you want to use the lines, excellent. If you want to skip ahead to this page and use the flower without lines, you can do that too. If this is a little too tricky, just go back to this page. Same with your rhombus. If this is a little too tricky, go back to this page. That's your assignment for today. That's how we find area using different units of measurement. Good luck with your work, and I will see you later today, or Mr. Ratter and Mrs. Hedstrom will see you later today to talk about what we understood and what we still have questions about. So good luck with your work, and we will see you later today.